This is CPE 233 Experiment 2. This is the program counter, otherwise known as the PC. Well, there's actually two parts of this experiment. You're actually going to implement some hardware, which is the PC, as well as some support circuitry, which is essentially a MUX and some memory. And then you're going to test it. So you're going to test it via a program, partially, that is in the RISC-V memory. And what you're going to do is verify that you can load everything you need to into the program counter. You're going to verify that you can clear it, and you verify that the program counter can sequence through a program. So not a big program, it's only like 7 lines or something like that. The issue is whenever you test any digital circuit, the general rule is I'm going to tweak the inputs and verify I'm getting the correct outputs. Now, sometimes that's way too many inputs, but for this experiment, there's not that many inputs. We're going to actually test everything. Okay, so at one point, we're going to be checking that we can sequence through a program. The other thing, we're going to see if we can load all possible values into the register, which is essentially the PC. So over on the left is our, we're just going to call it the PC module. And it is essentially, even though it's called a counter, it's essentially a register, and you should implement it as a register. This register has the ability to input one of 4 values. Essentially, I'm not going to say input it, but it has the ability to load one of those 4 values into the program counter. So counters, since they are understood to increment, this is actually advancing by 4 every time. So even though we call it a program counter, like a counter, we should implement this as one of the registers. And make sure when you use a register to make sure you get rid of an asynchronous reset. Make sure you make the reset synchronous. So this PC mod here is this PC mod here. It's essentially talking to memory. Okay, now the issue here is I don't implement it like this. What I want to see is a flat design with 3 modules in it, which is a MUX, the PC, and the memory. Okay, this was just for demonstration purposes, and what I want you to do is to draw the final circuit, which means to not draw either of these, but draw a top level that has a MUX and a PC in it as well as a memory. So essentially, copy this top level, but replace PC mod with these 2 components. That's what I want. That's what I want to be hand drawn. Don't grab the elaborated design. Just do it this way. That's the best way to do it. Okay, so a bunch more details inside the lab manual. Check for those things. It also tells you what to submit. Anytime you submit a timing diagram, which is part of what you need to do in this thing, it needs to be annotated. No one likes looking at timing diagrams. What I want you to show is that the hardware works. And so I want you to draw my eyes to the important stuff being the proof that it is working. So once again, submit that as part of your lab submission, and then just ask questions along the way.